Chapter 13, we are still dealing with our maturity value formula in the first section. It's just now we're applying it to notes. So businesses maybe can issue out longer terms than, say they sell a customer a piece of equipment, and instead of just giving them 30 days to pay, maybe they're going to give them, 180 days, 220 days, some sort of a longer time frame. So in order to do that, they would enter into a note, which would be a legally binding, like IOU, is basically what a note is. So really we do the same formula, which is our maturity value is equal to our principal plus our interest, and then our interest is principal times rate times time. So we're still using the same formula. And normally our notes are also in terms of days, so our time is going to be over 360. Just again, different business scenarios. So say we have an example of Staples Office Supplies borrowed funds to buy a color electronic book and magazine readers to stock in all their stores in one district. A 320-day note at 7.8% with a maturity value of $304,000 was signed. So find the face value. So again, the terminology is a little bit different. Our maturity value is our future value. So that's $304,000. I'm sorry, I have that M, and I think I knew that the way that it is worded is maturity value, but it's our same future value formula. So maturity value, future value, same thing. So we fill that in there. Find our face value is what it's asking us. So the face value is another word for our principal. So then again, don't forget, you've got, if you're using this longhand formula, you've got one whole P here, and then we're going to have a decimal of a P over here once we fill in the rest of it. So our rate of interest was 7.8%. And then our time, again, is in days. It was a 320-day note. So almost a year. And then with these notes, almost always we put them over 360. I can't think of even one example that would say an exact interest, so just kind of, think 360, think ordinary interest. And again, this one is one of the ones that's a little bit harder, where we're looking for our principal, or in this case, the face value, as they call it, in the note. So we can multiply what we can here in our parentheses. So if I take 0.078, or 7.8%, if you like to use your percent button, times 320 divided by 360, I get 0.0693, and the 3's kind of just keep going, still multiplied by my P. And then what I can't forget here is I have one whole P on that part of the equation. So don't forget this, you know what I mean? And sometimes students do that, so leave that one whole P there. So basically you'll end up with 1.0693 times our P equals that 304,000, which is our future value or our maturity value. And then we divide both sides by that 1.0693 number. So if we take 304,000 divided by 1.063333, we get $284,289.28 if I round it up. So then that is our principal or our face value. So my other thing of word of warning is when you're looking at your test and it would use the words like present value or maturity value or future value in this area, don't use your time value of money keys. If you're anything in our current material on our test, we're going to go back to just our simple interest where we're using this formula here. So even though it uses some of those words like future value, present value in some of these problems, don't let that confuse you and go back to using your compound interest functions. You will have a part on your final that you have to do that in the comprehensive section, but not in this current material. Okay, then we move on to our next section. Section 2 deals with discounts. And a discount is not like a savings, like we think, hey, I'm going to go to the store and I'm going to get a discount. This is a way that the bank or could be even companies loan money, and they basically take the interest off the top. So our discount is basically calculated the same way as interest. It's going to be our principal times our rate times our time. But then our proceeds on the loan are going to be the amount borrowed minus that discount. So it's just a little bit different. So if you like to kind of put it into like that maturity value formula, you know, instead of it being plus the interest, it's minus the interest. So it would be our principal minus that interest, if that makes a little more sense to you. But it's not really our maturity value, because our maturity value is going to be the amount borrowed. So basically how it works is, you know, if you go and you borrow $100,000, they're going to subtract the interest and give you what's left, but then you still pay back the $100,000. So I kind of just keep it to that. Just know that it's the amount that I borrowed minus my discount. So if we have, say for instance, a Chevron employee bought a small boat with funds borrowed from First National Bank. He intends to repay the note with a Christmas bonus of $6,000 to be paid to him in 120 days. If he's given an 11% discount, find the amount of the discount and then the proceeds on the note. So again, our discount is going to be what he's borrowing, which is the $6,000. His discount rate is 11%. And his time is 120 days. And again, no mention of exact, so we put that over 360. So if I take the $6,000 that he intends to pay back, or the amount that he's borrowing, times 11%, or 0.11, times 120, divided by 360, I get a discount or interest of $220. So then, because it's a discount, the proceeds are going to be the $6,000 minus that $220. So he's going to be able to walk out of the bank with $5,780. So again, he's going to walk out of the bank today with $5,780, and at the end of this 120 days, he's going to pay the bank $6,000, and that's going to come out of his Christmas bonus. So then just make sure you kind of get your mind around that. What he leaves with today is not what he's actually paying back at the end. It's going to be that amount minus the interest. So in a sense, the bank is taking that off the top or keeping that interest, and then you pay back the full amount. All right, then we have one that shows us kind of the difference in that interest rate. So we have Faith Daigle signs an 8.5% discount note with a maturity value of $7,800 and a term of 8 months so that she can remodel her kitchen. Find the proceeds and then the effective rate of interest. So we'll go through our same steps here. The amount of discount that she's going to pay, she has $7,800 is the amount that she's paying back, and that's the amount that we're calculating the discount on. She has a discount rate of 8.5%, and then she has a time of 8 months. So in this case, we can just put it over 12. Our time is always in terms of a year, and if they give it to us in months, we'll leave it in months. So 7,800 times that 8.5% discount rate times 8 months divided by 12 months gives us a discount of $442. So then her proceeds are the $7,800 minus the $442. Because the $7,800 is the amount that she has to pay back at the end. So that gives us proceeds of $7,358. And then the second part has us using these proceeds figure out, well, how much is she really actually paying? She's not actually paying 8.5% because she really never walked away with that full amount. So to calculate out our effective rate, we have to take the amount of the discount that she's being charged, which again, I erased it because I needed room on the board, but it is the $442. That was our discount amount. The principal is the amount that she is paying back, which is the $7,800. And then we're trying to figure out what really effective rate that ends up being for that period of time. So that period of time still is the 8 months over 12. So if we go ahead and put those into our calculator, 7,800. No, and I'm sorry, I got that wrong. This is not the correct number. I apologize for that. We want to put her proceeds in there. What is she actually walking away with? Because if I do it the way I just did it, I'm going to still get that same 8.5%. So she's only walking away with the $7,358 proceeds. So being that that's the only amount of money she can use, but she's being charged $442 in interest, what does that rate represent? I apologize for that. All right, so 7,508 times 8 divided by 12 gives us $4,905 and threes that keep going. But then don't forget, we're still multiplying that by our R. And then when we divide both sides by that, our $442 divided by $4,905.33, that gives us 0.0901 or a 9% effective rate. So then you can see it's a little bit higher. You're going back to the problem, the discounted rate was at 8.5%. But again, because she doesn't ever walk out of the bank with that full amount she's borrowing, it's always less the interest. Effectively, they're charging you more. So that's what you want to be able to understand and kind of be able to compute. What is that effective rate? We know that the stated discount rate is 8.5%, but because we never get it all, it's going to increase that rate. Okay, then our last one out of section 13.3 compares a simple interest note to a simple discount note to kind of see the difference in interest that's being charged. So our simple interest is, again, that same formula there, taking us back to chapter 12. So we have Sean McTuff wants to borrow $6,000 for 180 days to purchase a used Harley-Davidson motorcycle. How much less interest is paid with a 12% simple interest note compared to a 12% simple discount note? So again, our calculation is our principal times rate times time for our interest. So we have with our simple, we just simply take the $6,000 that he needs to borrow times the rate of interest that they are charging him, which is 12%, times our time of 180 days. Okay, so 6,000 times 12% times 180 divided by 360. That gives me $360 in interest. Now then if we compare that to the discount, then this makes you think a little bit deeper into it, because if he needs $6,000 to buy this motorcycle, he's going to effectively have to borrow more in order to net the $6,000. So if we would go kind of back to our formula where we had our proceeds is going to be the face value minus the interest. And we need to have $6,000 in proceeds. How much would he need to borrow? And I'm going to switch this to that P just to kind of keep it used to the formula that we're doing. But then since now it's a minus because it's a discount, we subtract it. We're not adding it. Now we know the discount rate though is 12%, and we know the time is 180 over 360. So if we multiply this out, we'll figure out how much he actually has to borrow. So if we multiply what we can here, that gives us 0.06 times our P. And then now again, we're not adding, but we're subtracting, so that $6,000 is going to be equal to 0.94 of our P, and then we divide both sides by that. And that gives us $6,382.98 that they would need to borrow in order to net the $6,000. And then I'm running out of room on my board. But then to calculate what that discount is, if I kind of squeeze it in over here, it's going to be the $6,382.98 times the 12%, or we can just subtract it. We don't even have to go through the math of it. Just subtract the $6,000. So they'd have to borrow $6,382.98. They receive $6,000 back. They would be paying $382.98 in interest. So then you can see, then we could subtract those two to say that it's going to cost them $22.98 more between a simple interest and a discounted interest, because the logic is they would have to borrow more to walk out of the bank with that $6,000. So then that's kind of how we, in a long mathematical process, we figure out how much additional interest is charged comparing that discount to the simple. And then that is all we cover. We don't get into section 4 of chapter 13, so we stop there.